Hey everybody, back here doing some mastery quiz review. Mastery quiz number 14 for geometry has to do with probability. We just talked about geometric probability. We've thrown in some regular old geometry or probability that you'd probably find in an Algebra 2 class or advanced algebra or stats, or some basic probability information that we should all know by the time we're sophomores. So we want to throw this in here. Question number 1 says a card is randomly selected from a standard deck of 52 cards. What's the probability that it'll be a 7 or a spade? Alright, I'm choosing one card from a standard deck of 52 cards. If you're not familiar with this deck of cards, you might want to take a deck of cards, look at them, see what they're all about. There is a diagram in your textbook so you can help you understand how the deck of cards works. But what I want to do here to find the probability is find the probability of getting a 7. And the term or here is going to mean we're going to add. And what's the chances of pulling out a spade? Well, the chances of me picking a 7 out of a standard deck of cards is 4. 4 out of 52. There are 4 7s out of 52. There are 4 cards of each number, including the ace, the jack, the queen, the king. There are 4 of those each in a deck of cards. And how many are spades? There's 13 cards that are spades out of 52. Again, if you look at your diagram, get a deck of cards, take a peek. It'll help you understand where all these numbers are coming from. But the problem in this particular case is one of the 7s is also a spade. So that card has actually been counted twice here. So we have to subtract the probability of getting a 7 and a spade. Alright, so how many of those 7s are also spades? 1. So we're going to subtract 1 out of those 52 because that card can't be counted twice. When I do that, I add them up, I get 16 over 52. That's going to give me 8 over 26. If you keep going here, that's 4 over 13. And dividing that out will give me a decimal of 0.307. Okay. Question number 2. There are 20 students in the classroom. 5 sophomore girls, 7 sophomore boys, 3 freshman girls, 3 freshman boys, 2 junior boys. A student is going to be selected at random from the class. Just one student. What's the chances that that student will be a freshman or a boy? Okay. Similar question here. I want to find out the probability of picking out a freshman plus the probability of choosing a boy, but then I better subtract the probability of getting a freshman and a boy. So I can't be counting people twice, just like the last question. So I got to figure out how many of these kids are freshmen. Looks like I've got 3 freshman girls, 3 freshman boys. There's 6 freshmen total out of that group of 20. Add to that all the boys. How many are boys? We got 7 sophomores, 3 freshmen, 2 juniors. I think there's 12 boys there. Again, in this particular question, I hope you realize, wait a minute, some of those boys have been counted twice, right? The 3 freshman boys are counted as freshmen and boys. I have to take away those 3. Can't count them twice. And I add all those together. I get 15 out of 20, which is, of course, 3/4 or 0.75. Question 3. Here you're going to randomly select marbles from a bag. Okay, your bag has 15 gray, 12 purple, 32 orange, and 11 pink. What you're going to do is choose a marble from a bag, and then you're going to choose a second marble from a bag, but you're not going to replace the first one. So that's going to change things a little bit. In this particular case is asking what's the chances of pulling a gray marble first and then an orange marble second. Here we're using the word and. We are going to multiply. So I'll take the probability of gray times the probability of getting an orange. Okay. Probability of choosing a gray, well, there's 15 gray. 15 gray out of a total of, I think there's 70 marbles total. Okay, that's pretty self-explanatory, but now think about it for a second. The gray marble I picked is in my hand, yet now I reach in for the second marble. That changes things a little bit, doesn't it? What are the chances now that I can pull out an orange? Well, there's still 32 marbles that are orange. The number that changes is the 70, because there's not 70 marbles in the bag anymore. There's 69. And I'll go ahead and multiply those numbers together. Take care of this real quick here. You get 480 over 4,830. You can reduce that all the way down to 16 over 161, and that'll give you a decimal of 0.099. Now my notation up above here in the probability section here, this is probably better off written as what are the chances of choosing an orange, provided there's probably a solid line there that a gray has already been picked. It's a conditional probability question. My notation wasn't done very well there, but I did make that number change right here just by thinking it through. Question 4: a teenager wants to pick 6 outfits from for a vacation. She's got 18 outfits to choose from. How many ways can this teenager select 6 outfits from 18 total? Well, think about it. You got 18 groups of clothes laying there, and I want to pick 6. How many different ways can I do that? This is a permutation and a combination type of problem. We have 18 total things to pick from, and it doesn't really matter of the 6 I pick which one I would wear Monday, Tuesday, Wednesday, Thursday, or whatever. It doesn't matter which there's no condition here. I just want to take 6 outfits with me. It doesn't really matter which outfit I would pick first or second or third. This would be a combination problem. So we'd write 18C6. You should be familiar with that notation. And once you got the permutation or the combination thing taken care of, the combination is what you're going to use here, because the order in which you're picking the outfits doesn't really matter. You're just picking 6 outfits. And now you'd grab your calculator, punch that in, and this number is a pretty large number here, 18,564 ways. That's a lot of different outfits there. 18,564 different ways you can pick 6 outfits from a group of 18 when the order doesn't matter. Next question. A graduating high school student is headed off to college. Needing to take only what is necessary, the student decides to give 3 video game cartridges away to its siblings, brothers or sisters, doesn't matter. The 3 video games are taken randomly from a selection of 9. How many different ways can the student distribute the 3 videos from this collection? Now, your first question is this a permutation or a combination? Does the order in which I pick these 3 matter? And this it does, because you're not just picking 3 videos of the 9 to give away, you're picking 3 videos to give to a particular person. So the order does matter. This would be a permutation problem. So you have 9 things to pick from total. It's a permutation because the order in which you give the games out matters. So 9P3. Again, grab your calculator, crank it out. You got 504 different ways that you can do this. 504 different combinations or permutations of distributing those 3 videos to your siblings. Well, that should do it. Hopefully that helps. Good luck.